In this video, I'm going to show you how to complete the Lab 3 Data Science Essential, which is hypothesis testing. Okay, so there are two parts. The first part is in the R, and then the second part is using the Python. So for the R, we are going to use the RStudio again. Yeah. So first, we open the RStudio and then load the dataset using this command. Okay, so we set up the working directory, which is going to be set to my folder where I have the data located. Okay, so I'm going to open my RStudio. Okay, then previous script was deleted. If you want to save, just save first. Yeah. Then after that, Control L to delete. Then also click this groom to erase everything. Okay, so create the R script. First, set up the working directory first. So follow the tutorial here. Yeah, session set working directory. Okay, to choose the directory, which is in this case is this one. This is my folder. Okay, then after that I'm going to read the data using this command. Okay, I don't have the folder data, so I just go directly to open this here, and then I clean the command. Okay, so read the CSV, but I will put this everything in the script. Okay, so I just copy this to the script. Okay, after it run. Okay, good. Yeah, so the data found, and then I already read into the memory. Okay, the next is to run the head Carlton. Yeah, to test the data. You want to testing to preview the data. Okay, so head Carlton. Okay, so this is the example 6 row from the dataset. So there are 934 cases. Okay, it's not shown here, but don't worry. Yeah, later we're going to use the other command to display the statistic. Okay, so create a function to plot histogram with the name hisplot. Yeah, use the code here, and then create a function to call the function. Then compute the pin width, and then create the first histogram, second histogram, and then stack up the histogram. Okay, and then after that declare the sans variable, call the function his family to produce the script. Yeah, okay, so let's create the script. I will copy everything here first, yeah. Then after that I will comment out some. Okay, here you go. So put in the RStudio. Okay, yeah, visualizing some relationships in the data. Okay, yeah, so This one I already have the grid extra, so I just load into the library. Okay, then create the histogram, and then create a function to call, and then set the pin as 30. And then continue creating the first histogram and computing the pin width. And the last part, create the second histogram and then stack up the histogram. Yep. So I'm going to select this, run. Okay, so let's call the code to produce the plot. Okay, yep. Okay, in this two histogram, the first one is displaying the height of the child and how many forms kind of the distributed normal, yeah, similar like the count also, yeah, how many of the mother, yeah. Okay, after that we continue. So distribution of the height of the mothers and the son have a fair degree of overlap. The mean height of the sons is noticeably greater than the mothers. Yeah. So in average, the boy, the son's height is taller than the mothers. Yeah. Okay, then you're going to compare the height of the mother to the height of the daughter. Okay, yeah. So declare the son variable with the gender male, and then using the call the histogram family, passing the son and the child height and the mother, and then after that the daughters, child height and mother. Okay, this is done already. Yeah. Now we're going to do the additional chart. Okay, yeah, so this is the child height and the mother, very much close to each other. Okay, yeah, so take note, the distribution of the height of the mother and the daughters overlap almost entirely. The mean height of the daughter is nearly the same as the mother's. Yeah? Okay, then we're going to apply the test to examine the relationship between the variables in the data. Yeah. So a few things about the test is the confidence level 5% or 0.05. Yeah. And then determine, if the p-value is less than confidence level, then the small p-value indicate the probability of the difference of the means being more extreme by chance alone is small. Yeah? So we reject the null hypothesis when the p-value is less than 0.05. Okay, yeah. Okay, so we create a function. Histogram family. Okay, run to produce the plot. Then we call the code to call this function. Mother and the child height. Okay, this is the confidence interval. So find the p-value here. So very small, yeah, 0.2.2 something. So because it's very small, then we reject the null hypothesis. Okay, we continue. After son's mother child height, so p-value is less than 0.05. Yeah, we reject hypothesis. Okay, then after that we continue with the father. Yeah, father and the daughters. Okay, so this is the relationship between the height of the daughters with the father. Yeah, in the relationship the child height. Okay, so let's see the p-value of this test. Yep. Okay. This one. Yeah. Because this is more than 0.05. Yeah. Then we fail to reject the hypothesis. Okay. That's how to complete the lab 3 in the RStudio. Thanks for watching.